In programming, iteration is the process of repeating a block of code multiple times, and it is a fundamental concept in controlling the flow of a program. Iterative constructs, commonly referred to as loops, allow tasks to be automated and repeated efficiently without the need to write redundant code. All loops are controlled by conditions, which determine whether the iteration should continue or stop. These conditions are evaluated before or during each repetition, ensuring the loop behaves as intended and avoids unnecessary execution or infinite cycles. For instance, a loop designed to process all the items in a list might use a condition to check whether it has reached the end of the list, halting once every item has been handled. One of the most common types of loops is the for loop, an example of a count-controlled loop. Count-controlled loops execute a block of code a specified number of times, and their behavior is explicitly determined by a counter variable. The for loop typically requires three key components: the initial value of the counter, the condition that specifies the stopping point, and the step by which the counter is incremented or decremented after each iteration. For example, in Python, a for loop iterating over a range of numbers might be written as for I in range 1, 6, which would execute the loop body 5 times with I, taking the values 1, 2, 3, 4, and 5 in succession. This type of loop is particularly useful when the number of repetitions is known in advance, such as printing a sequence of numbers, iterating over the indices of an array, or generating a specific pattern. Nested iteration statements occur when a loop is placed within the body of another loop, creating a hierarchy of loops. In nested iteration, the inner loop completes all its iterations for each single iteration of the outer loop. This structure is invaluable when dealing with multidimensional data or tasks that require repeated operations within repeated operations. For instance, consider the task of printing a multiplication table. An outer loop might iterate over the numbers 1 to 10, representing the rows, while an inner loop iterates over the same range, representing the columns. Within the inner loop, the product of the current row and column numbers can be printed, resulting in the full multiplication table. While nested loops are powerful, they can become computationally expensive, especially when both loops have large ranges, as the total number of iterations is the product of the ranges of the outer and inner loops. It is crucial to manage loop conditions carefully to ensure correct behavior and to prevent errors such as infinite loops. An infinite loop occurs when the condition controlling the loop never becomes false, causing the program to repeat the same operations endlessly. This is particularly problematic in count-controlled loops if the counter is not updated correctly, or in condition-controlled loops if the condition cannot logically be satisfied. For instance, a while loop designed to iterate until a variable reaches 0 must ensure that the variable is modified within the loop. Otherwise, the condition will always evaluate as true. In summary, iteration is a cornerstone of programming, enabling efficient repetition of tasks through loops controlled by conditions. The for loop exemplifies a count-controlled loop, ideal for situations where the number of iterations is predetermined. Nested iteration allows for handling more complex repetitive processes, such as those involving multidimensional data. However, careful attention to loop conditions is essential to ensure that iteration constructs perform as intended and do not lead to errors or inefficiencies. Through the appropriate use of loops, programmers can create elegant, reusable, and scalable solutions to a wide variety of computational problems.